Hi, I'm Jeff Yarger. I'm a professor of chemistry, biochemistry, and physics at Arizona State University. What we're looking at today is what I affectionately call Pchem Cloud Lab, or remote access to instrumentation at Arizona State University for online students taking a physical chemistry laboratory or chemistry and biochemistry laboratories. And this one, what we're looking at today, is a demo of an acoustic interferometer, which is a pretty hands-on instrument for looking at some of the basics of gas properties. What we measure is the speed of sound, and from that we relate that theoretically how sound propagates through gases to a ratio of its thermodynamic heat capacity values for those gases. So we can look at various gases and from some simple measurements deduce some thermochemical properties of these gases. So what I'm going to do is, this is a demo of a live demo of looking at this system. So this is AnyDesk, which is a VNC, a virtual network connection. AnyDesk, No Machine, Mesh Central, Microsoft Remote Desktop. What we're going to do is basically log into the computer that is running this at ASU and pull it back as though we were sitting at the computer directly. And that machine using AnyDesk is given this alias, mrrc _ data _ workstation _ 2 at AD, which stands for AnyDesk. And this is our current system. So when we connect to it, we're asked for a password, which is given to students in the ASU online course. And then furthermore, now we're logged into that computer that is controlling that instrument as though we were sitting at the computer directly. So this is ASU Online Chem 343, and again, students are given a password for getting onto these systems. And now we're logging into it, and we're logged into this system the same way we would if we walked up to it physically at ASU. And to show that, I go through, so that's AnyDesk. Now we're into that system. We're going to use Audacity to do this speed of sound measurement. We use OBS we have several video cameras so that we can look in real time at what's going on. And then finally, we have something to control the gases as well. And then we have some cloud-enabled drives. So I'm going to start here. We're going to want gas flow. This is a script that's running in Arduino that's computer controlling these gases. We'll see that in a second. So this takes a few seconds to run. Once it does, it's going to come up and ask for how it's connected, etc. This specific one, there'll be, this can vary detail to detail, but this one is connected to COM4. And then it will pull up a script that allows you to control the purge rate and gases for these. Okay, I'm going to put this over here. We'll come back to that in a second. Now we're going to go up the chain. We're going to start OBS. And let's start by looking at kind of the overview of this. So here it is. This is the computer that we're logged on to as though we were sitting at this keyboard and mouse directly. You can see as I move this, it's in real time looking at that. So, here is one view. We can also look, at the tanks from this other view. You can see there's a camera here. There's a camera there that's looking at the flow meter. This is looking at a close-up of the system. So let's do that. This is the kind of overview. Then we'll look. This is the acoustic interferometer, the gas hookups, the tube that it's going through, the gas inlet, outlet. Over here is the speaker, which is an earbud, and then the microphone that we're using. So our entire setup, and we're going to go back to kind of this overall view. Okay. Now that we've seen we have control of the gases, we can see the gas cylinders, the system in real time, a live view. And we're able to run this system as though we were sitting at this keyboard and sitting at the instrument directly now. So what are we going to use to both generate sound as well as detect it? Audacity is a very common audio program, freely available. So I've chosen this one. There are numerous applications you could use for this. On here, it shows you have a selection of what the microphone you're going to pick up. It's this microphone. It's given the information here. And then it's the earbud or the headset here is what we're going to play the sound through. Let's pick a project rate that makes sense for this type of measurement based on the acoustic interferometer handout and information, background information that's been given to you on this project. Now we're going to want to generate some sound on this side. So let's take a kind of a close-up look at the system. We're going to want to generate sound over here and detect it over here and eventually flow gases through this, different gases, and see how it changes those measurements. So we're going to start by, we need to generate some sound. The most common thing is to generate noise. We'll generate white noise for 30 seconds at an 11 kilohertz rate. So that's some noise. We could even give it, if we wanted to, a name. White noise at 11 kilohertz project rate. Then we could add another track. We only need one channel. We don't need stereo on here. And we want this track to record this microphone. At the same time, we want it to play this. So it's going to play here and record here. We've selected this channel, and then we just hit record. When we do that, hopefully you'll be able to hear this. It comes through on any desk as well. We can hear the white noise playing. It's also playing, of course, through here. And then what we're detecting is this microphone. And this is the resulting microphone detected while it's playing this white noise. So we're going to let it play for all 30 seconds and then even record a few seconds at the end of what should be the ambient noise in the room or the ambient noise that this microphone picks up through this tube when there is no sound being played. Okay, now did this work? Well, let's start by, this is the other nice thing about Audacity. We can quickly just grab part of it and do a Fourier Transform, which is this plot spectrum. This is what we expect for white noise. It's consistent across from 0 to 50 to 5.5 kilohertz. Or half the project rate. And if we look at what we recorded as that white noise is playing through the microphone that goes through that tube with the same plot spectrum, you'll see here there are oscillations. There's some fast ones, and then there's these oscillations here, which are the resonant modes of for the sound going longitudinal resonance modes through that tube. So by knowing the length of the tube, we would be able to then figure out the speed of sound for that gas. So we could also play around with this, the microphone gain, the speaker volume, etc., to try to reduce some of this additional oscillatory noise here. We can also play around with several different processing parameters, etc. But let's get to one specific, which is, so we can mute this channel, we can add another one here and select, and let's do, kind of let's select helium, and start purging helium. And we can view that by looking at the flow meter one here. And so we can see that now helium is flowing through that system. And we could record data. You can select this channel. It's through the right one that we're, we don't need to do it through both earbuds, etc. So we could select this channel, mute this one, it'll still play this one, and we can start recording again while it's playing. You can see it's no longer flowing gas. We can make it purge gas again. You can even see kind of where that starts. And now, so this is kind of while it's not purging, this is while it is purging. So we could make note of that in our lab notebook, etc., of what's going on. But we can record either while it's flowing or after it's flowing, etc. And you can just see, obviously, there's a significant change. We can record some while there's no sound going through as well. And so, if we look at this, kind of while helium's flowing and analyze this, you see these resonant modes are much different now than they were, for example, here in this kind of same window here, right? So we're seeing differences of the recorded data. As you would expect, helium, I can even make some predictions. You expect the resonance modes to be to higher frequency. Helium's a lighter gas. It has a much higher speed of sound through it, which is why your voice goes up as you breathe helium and go through. So that shows two of them. You can see you have a selection of 4 different gases. You can purge for different amounts of time. You can not only do white noise, you could, for example, chirp different frequencies and look at it. You have a lot of versatility here on this remotely accessible instrument to remotely collect data. And then you can, save this data as a project and, send it over to a cloud drive, Google Drive, or one of the Dropbox or some cloud drive, so that you have access to this data and you can pull it up on your own version of Audacity and do further analysis. So you can really just use this for collecting the data and analyze it later. But at least kind of on the fly, you can make sure the data is looking good in real time as you're collecting it and doing things. So hopefully that gives you a brief kind of hands-on overview in the same modality that anyone would access this system. And for more information, you can go to biopchem.education, which is a publicly available site where there's background information as well as links to how to get to this, etc. Thank you.